identify the units you are starting with. Second, identify the units you want to end with. Third, find the conversion factors that will bridge the starting units with the ending units. And 4, set up the multiplication problem so that all the units, except the units you want to end with, will divide out. How can we apply this? So, let's say a sheep rancher is making new lambing pens for the upcoming lambing season. Each pen is a rectangle, 6 feet wide and 8 feet long. The fencing material he wants to use sells for $1.36 per foot. If he's planning to build 5 separate lambing pens, how much will he have to spend on fencing material? So we can figure out how much it's going to cost for one pen, and then we can multiply it by 5, or we can figure out how much all of the fencing material will need, and then multiply it by how much it costs per foot. So what I'm going to do is I'm going to figure out what it's going to be per pen, and then figure out how much it's going to be in total. So our perimeter equation is 2L plus 2W. This is for one pen. I know that my length is 8 feet and my width is 6 feet. And yes, I have the units of measure there. 16 feet plus 12 feet is 28 feet. So for each pen, it needs 28 feet of fencing material. So the cost of one pen is going to be 28 feet times $1.36 per foot. That's what this means, per foot, because I've got to get rid of the feet. Otherwise, I'm going to have dollar feet, and that makes absolutely no sense. So we cancel out feet, and we are left with $38.08 per pen. But we want 5 pens. So the total cost will be $38.08 times 5 for a total of $190.40. That's not bad for 5 pens for a business. So Robert McKeague became the first 80-year-old to finish the Ironman Hawaii Triathlon. Now the triathlon is biking, swimming, and running. And in the running portion of the race, he completed the 26.2 miles in about 6 hours. So what was his speed in miles per hour? So we know that 26.2 miles per hour, we need to divide it by the 6 hours to get what it is per hour. So his speed was 4.36 miles per hour. If you notice, none of the measurements canceled out here. These are measurements that there's not a conversion from miles to hours. There's not a conversion to hours to miles, because one is a measurement of time and one is the measurement of distance. But it's okay to leave it in form of how far can I get in a block period of time, an hour. So we have miles per hour. For the metric system, kilometers per hour. Here's an example I'm not too sure I can relate to because I'm in California and we don't get a lot of snow, at least not on ground level, and up in the mountains we do. But a ski resort in Vermont once advertised their new high-speed chairlift as the fastest chairlift with a speed of 1,100 feet per second. Well, we're going to prove them wrong. Now, I'm not too sure what feet per second feels like, but I am familiar with miles per hour. I drive a car all over California, and therefore I'm very familiar with what 20 miles per hour feels like, as well as what 70 or 80 miles per hour feels like. So I'm going to convert feet per second to miles per hour. So I need to convert the feet to the miles as well as the seconds to hours. So there's going to be 2 conversions going on here. So here's what I need to do. 1,100 feet per second, I need to change the seconds into minutes, and then the minutes into an hour. Now, I want the hour to end up on the bottom, so therefore I chose the conversion factor to be able to cancel out the seconds and eventually cancel out the minutes. Now, all I need to do is change the feet to miles, and I do have a conversion factor that is the 5280 feet in a mile, and since I want to end up with miles in the numerator, I definitely want to cancel out my feet by putting my conversion factor of feet in the denominator. Right? So ultimately, I'm going to get, cross that off there, I don't need it. Seconds will cancel out seconds, minutes will cancel out minutes, I'm left with hour. Feet will cancel out feet, leaving me with mile. So here I go. I have 1100 times 60 times 60, and miles are in the numerator. I am only left with 1 times 1 times 5,280, and everything else canceled out to leave me with hour. I have 3,960,000 miles per 5,280 hours. And that reduces down to 750 miles per hour. So there is no way that a chairlift would go 750 miles per hour. In fact, it probably hurt the people that were riding it. Maybe they could build it to go 750 miles per hour, but certainly it would not be a comfortable ride. So that's it for this portion